Okay, welcome back, parents and students. It's Mr. Young here. So one thing I want to talk to you guys about really quickly is mathematical literacy. Imagine all the languages around the world. Mathematics is one of those languages that is universal, that no matter what you speak, we can all agree that mathematics is what we can communicate on. So that being said, vocabulary words, when we go through with this course or throughout life, it is very important that you understand these. That way you understand what's being asked of you when you solve math. Okay, ladies and gents, so what I want to do is I want to continue with 1.1. So this is part 2 of 1.1. And I do want to continue with perfect squares. Earlier in the last video, I showed you some examples of what a perfect square is. But just know that a perfect square is a number that can be made by multiplying a whole number by itself. Okay, so what we want to do is look at the relationship between perfect squares and its square root. This is what you would call a radical sign. So if we have the square root of 25 and the square root of 30, we could say that the square root of 25 is 5. Why? Because if we have 25 dots in a 5 by 5 type of grid, here we have 5 columns by 5 columns, and so we have that square. So 5 times 5 is 25. Now the root would be the 1, 2, 3, 4, 5 on the bottom. So 25 is a perfect square. And also 5 is a prime number. The square root of 30, on the other hand, is approximately 5.48. 30 is not a perfect square. All right, so using 25, using the factor tree, we have 25. The two factors that make 25, you could say 5 and 5. Now 5 is prime and also 5 is prime. So if we multiply these two together, we get 25. 30, on the other hand, we know that 3 times 10 equals 30, and also 2 times 5 equals 10. All right, so if we circle those, 2 is prime, 5 is prime, and 3 is prime. Just remember that for a perfect square, it is a number that is multiplied by 2 identical factors. So 2 identical factors is 5 times 5. They're identical. That equals 25. But here we have different prime numbers. Using the associative property of multiplication, no matter which way you multiply these numbers, yes, it's still going to equal 30. However, 30 is not a perfect square, because no matter which way you multiply using the associative property of multiplication, it is still not going to be a product of a number of 2 identical factors. The first 10 perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. We get that by multiplying 1 times 1 to equal 1, 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 16, 5 times 5 equals 25, 6 times 6 equals 36, 7 times 7 equals 49, 8 times 8 equals 64, 9 times 9 equals 81, and 10 times 10 equals 100. In other words, guys, 1 squared is going to be a perfect square. 2 squared is a perfect square. 3 squared is a perfect square. 4 squared is a perfect square. 5 squared is a perfect square. 6 squared is a perfect square, because again you have 1, 2, and that's your exponent squared. 6 to the power of 2. 7 squared is a perfect square. 8 squared is a perfect square. 9 squared is a perfect square. And 10 squared is a perfect square. So notice that you do see patterns here. If you look at it this way, you know you have the square root of 4 is going to be 2. The square root of 9 is going to be 3. The square root of 16 is going to be 4. Square root of 25 is going to be 5. And remember that a square root, again, is a number that is a product of two identical factors. Okay? Square root of 36 is going to be 6. Square root of 49 is 7. Square root of 64 is 8. The square root of 81 is going to be 9. And the square root of 100 is going to be 10. But to make it easy again, these are also two-dimensional. Okay, so you have your y-axis here and your x-axis here. So two-dimensional, you have a height and you have a width. Let's go and focus on 9, square root of 9. So here's my square. Now again, my height, I have a height of 3 dots. I have a width of 3 dots for my x-axis. So two-dimensional, okay, which is this exponent as well. Okay, so again, you have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the 3 dots on the bottom for the root area is going to be 3. So again, the square root of 9 is going to be 3. The fun thing with mathematics is that there's always a pattern, and everything there's a relation to something. All right. Again, please use the prime factorization, in other words, factor tree, to find if a number is a perfect square or not. Okay, so word problems are everyday life problems. Later in life, when you go and have a job, you're going to have a boss that's going to tell you to move that product in that warehouse. And then you're going to have to do some math. One strategy that you could use is what we would call buck. Think of money. You want to box your answer. You want to underline the information that's needed, circle the vocabulary, and then knock out any unneeded information. And I believe that this is number 54 in your book on page 8. So the word problem reads as, a square painting measures 2 meters on each side. What is the area of the painting in square centimeters? So the first thing you do is box the question. Questions usually start with the word what, how, where, all right? So what is the area of the painting in square centimeters? Always ask yourself that question. What am I being asked? What am I being asked to find? All right, so there's your question. Next, what you want to do is underline the needed information. A square painting measures 2 meters on each side. So it measures 2 meters on each side. All right. Next, circle the vocabulary word. Meters would be a vocabulary word. Square would be a vocabulary word. Measures would be a vocabulary word. Area would be a vocabulary word. Centimeters. Okay, these are vocabulary words. We already have squares, so I didn't circle that. All right, so here's something random. You have meters and centimeters. That's not the U.S. customary system. What we're used to is feet, miles, inches, gallons, pounds. All right, that's what we're used to, is the U.S. customary system. This is the metric system. Now, the fun fact is that throughout the entire world, there's 3 countries that use the imperial system. That's the United States of America, Libya, and I believe Myanmar. I think that's how you pronounce it. It's a country in Asia by like Burma and Vietnam. So for the metric system, I have a little ditty for you guys. King Henry doesn't usually drink chocolate milk. Okay, So what this stands for, you have kilo, hecto, deca, then you have the unit, deci, centi, and mille. All right, so this is with the metric system. Again, the majority of the entire world uses the metric system. All right, so think of this as stairs. At the top of the stairs is the largest item. The bottom of the stairs is the smallest. So mille would be the smallest, kilo would be the largest. Now for your units, you have liters, meters, and grams. Liters would be like liquid measurements. Meters would be like a distant measurement, how far. Grams would be like weight, how much does this weigh? So again, the metric system, King Henry doesn't usually drink chocolate milk. Kilo, hecto, deca, unit, decim, centi, mille. For example, since we have meters and we're working with I guess like a measurement of distance, height, width and all that, that would be like kilometers, hectometers, decameters, meters, decimeters, centimeters, and millimeters. If we were working with a liquid measure like liters, that would be kiloliters, hectoliters, decaliters, liters, deciliters, centiliters, milliliters. And if we're working with like weight measurements, like with grams, that would have been kilograms, hectograms, decagrams, grams, decigrams, centigrams, and milligrams. With the metric system, everything is in a base 10 system. And if you ask me personally, it's a whole lot easier to work with. Okay, so to solve this word problem, we're going to use the acronym BUCK. Again, boxy question. What is the area of the painting in square centimeters? That's what's being asked, and that's what we're going to find. We have also underlined the information that is needed. Measures 2 meters on each side. So in that case, we have that square painting, and it's 2 meters on each side. So the height is 2 meters. The width is 2 meters. Okay. Now, what we're asked to find is what is the area of centimeters. Again, keep in mind that area, we're also being asked to find the area. Area equals the length times the width. If we have 2 meters here, and we want to know, and we're going to go to centimeters, we're going to find out how many centimeters are in 2 meters. So we're going to go from decimeters to centimeters. So in other words, we just move that decimal point to the right twice. So 1, 2, and then put our decimal point there. So we will also say that 2 meters is equivalent to 200 centimeters. So if they're equivalent, 2 meters is equivalent to 200 centimeters, then the height is 200 centimeters. The width is 200 centimeters. All right, so then all you do here is measure to find the area. Again, length times width. The area is, the length is 200 centimeters. The width is also 200 centimeters. Okay, to make things easier, 2 times 2 is 4, and then just count the zeros. 1, 2, 3, 4 zeros. So just plug them in. 1, 2, 3, 4. Put a comma around after the thousands place. And then we can also say, don't forget your measurement. The area equals 40,000 centimeters squared. And lastly, students, Notice that I have a box around my final answer. I need you guys to start doing that. But also, you were asked a question. The area is 40,000 centimeters or square centimeters. All right, so don't forget to answer that question. All right, so I hope you guys enjoyed this. Again, use Buck, put a box around the question, underline the needed information, put a circle around the vocabulary words, and knock out any information that you don't need. And what we want to really target here is your critical thinking skills. So for my students, I always tell my previous students that you are all problem solvers, and what we're really trying to strengthen here is your problem solving abilities. Life is going to give you a lot of problems. Now, math is a good teacher. It teaches you to stand your ground, face your problems, deal with them head on. Don't quit. Don't give up. Persevere. Keep trying. You will get it. All right? So again, what we're building here is great leaders, great problem solvers, great thinkers. You're the future. All right, so always remember that. If you have any questions, reach out. You know my cell phone number. Have a good day.